Hey, let's look at subtracting mixed numbers. And we're going to start with no regrouping, which means that we don't have to borrow anything from our whole number parts. We'll look at that in the next video. So let's start with, again, just as I've been doing before, let's start with one with easy denominators, and then we'll move on to one with harder denominators. So our one with easy denominators is going to be 6 7/8 minus 2 5/6. All right, so again, 6 and 8 both share a common factor of 2, so we're going to be able to find something less than their product as a least common denominator. So 6 times 8 would be 48. We're going to be able to find something less than 48. So if I start skip counting by eighths, I've got 8, 16, 24, that's it right there. 6 goes into 24 also. So I'm going to get set up here. All right, so then I need to say, well, I'm going to have a 24 as a denominator here. So how many times does 8 go into 24? Or in other words, 8 times what is 24? That would give us a 3 there for 3/3. And then 6 times what is 24? That would be a 4 right here. Right, so here I'm going to have 21 24ths. Again, 7 times 3 is 21, 8 times 3 gives me 24, and then here 5 times 4 is 20, and 6 times 4 is 24. Okay, and again, let me just reiterate that this is a separate problem for right now. Again, when we start talking about with regrouping, that will be a little bit different. We're going to have to borrow from one of these, but for right now, because this numerator is larger than this numerator right here, we can just subtract. So I'm going to do 21 24ths minus 20 24ths. Again, we're just subtracting numerators. And so we end up with 1 24th. And then here we're going to do 6 minus 2, and we get 4. Right, in the end, we're just going to combine these. Again, we're not going to say, oh, it's subtraction, now I have to take 1 24th away from 4. No, we subtracted here, we got 1 24th. We subtract here, we got 4. And so our answer is going to be 4 and 1 24th. Right, and it's pretty clear from the numerator here that there is no reducing that's going to happen. 1 is neither prime nor composite, but even if we said, oh, they both have a common factor of 1, it doesn't change this value of either of those. And so it doesn't reduce. It's already in lowest terms, and so our answer is 4 and 1 24th. All right, let's look at the next one that has harder denominators. So this time I've chosen to do 7 and 41 50ths minus, and this time we're just going to do a proper fraction. We're not going to do a mixed number. 32 45ths. All right, if you want, you can think of this as being a 0 there, or just like you do all the time with subtraction. When there's nothing below it, you just assume it's a 0. So I'm going to leave it like that, just as we normally have when we subtract. That when it's a blank spot, we're assuming it's a nothing that we're taking away, or a 0. Okay, so let's talk about these denominators right here. So for this one, again, 50, we could pretty easily name the multiples of 50, but maybe not so much for 45. So we're going to do prime factorization. All right, so we'll look at 50 and 45. 50 is 5 times 10. That's a prime. And then we've got 2 times 5, both primes. All right, 45, I'm going to go with 5 times 9. 5 is a prime. And then 9 is 3 times 3. All right. So when we write them out, I'm trying to decide what I'm going to write first. I think I'll write 50 first because that has the lower prime. Again, the lowest prime here is 2 and the lowest prime here is 3, so I'm going to write 2. And then I know I need to leave some spaces for some 3's right here, so I'm going to leave a little bit of space, and then I'm going to do the 2 5's right here. Whoops, that looks like 55. Okay, and then for 45, I'm going to go with, again, I don't have any 2, so I'm going to skip that spot. I'm going to put 2 3's there and a 5. All right, so everything lines up there. I'm going to circle now what they have in common. So just that single 5 is all they've got in common. And then I'm going to bring down everything that they don't have in common. And that is our LCM, again, or our LCD, depending on which part you're thinking of. Okay, so then let's multiply these together. Now, we could do what we had done before and say, well, this part gives us 45. Well, actually, that does work pretty nicely here, because then all that's left is a 2 times 5, and that's a 10. I was going to say we could make a 10 first, but that works out nicely. So this is going to give us a 45 times a 10, which is going to give us 450 as our least common denominator. Okay, so let's go up and put that in. Okay, so now we're going to say, well, how many times does 50 go into 450? How many times does 45 go into 450? Again, this one's easy because it's just a multiple of 10, 10 times 45. But again, if you didn't recognize that, we would come down here and we would say, what did the 45 contribute to the 450? Well, it contributed 2 3s and a 5. What did it not contribute? It did not contribute this 2 and 5, which multiplies together to give us 10, which would be another way we could say this should be 10. And then what did the 50 contribute? Well, the 50 gave us 2 5s and a 2, so I'm going to circle those two things, 2 5s and a 2. So what did it not contribute? It did not contribute these 2 3s. All right, and those 2 3s multiply together to give us 9, and so this has to be 9. Okay, let's multiply them. 32 times 10, again, that's a lovely product there. And then 9 times 41, 9 times 1 is 9, and 9 times 4 is 36, so 369. Again, don't forget that we're subtracting. All right, so I'm going to subtract. 9 minus 0 is 9. 6 minus 2 is 4. 3 minus 3 is nothing, all over 450. And then here, we're going to do the 7 minus nothing, which is 7. All right? So again, we did not have to regroup. In other words, we didn't have to borrow anything here to do the subtraction. And when I say that, I mean borrow from this. It was not the case that this was, like, had these been reversed, we would have had a problem. But because this numerator was larger than this denominator, we just subtract. Even if we have to regroup within this part right here, like let's say this had been 380 and we had to go over and borrow from the next 3, that would still not have been, oh no, let's say it had been 280 where we had to do some borrowing here. That's fine. It's as long as we don't have to come over and borrow from the 7 that makes this no regrouping. All right, so let me put that back as it was. All right, so we've got 7 and 49 450ths. And again, our last time that we're going to use this is we're going to say, can this reduce? All right, so I know that in order for it to reduce, they have to share a common factor. I know all the factors of, or all the prime factors of 450. It's only 2s, 3s, and 5s. Right, and so I can say, well, I just have to check 49 to see if there are any 2s, 3s, or 5s. Now, you might say, I don't need to check. I know that this is only 7 times 7, therefore they're not going to have anything in common. That is very true, and you could say, yep, that's fully reduced. If you didn't recognize that, then you would have to go through and check all of these. So, does 2 go into 49? Well, no, it can't, because the last digit, the ones digit, is not an even number. Does 3 go into 49? Well, let me add them together. 9 plus 4 is 13. 13 does not go into 3, so 3 does not go into 49. And then 5, does 5 go into 49? Nope. It has to end in either a 0 or a 5, and it does not. Okay, so then that is fully reduced, and we're done.